two values. That value would be the first quartile, okay, the first quartile. And with respect to the upper 50% of values, also from the median up to the largest value, okay, we have another value in this particular range, okay, that would cut this particular data set in half, okay. So once again, we've got 1, 2, 3, 4, 5, 6 values here. So the value that cuts it in half is, get rid of the extremities, the value that would cut it in half would be halfway between these two values here. So what we have is we'd have a value that's halfway between those two values here. This value here is the third quartile, value, okay. And what these three lines give us is they give us a box, if that makes sense. So we actually usually put a box along. We actually I suppose, create a box around those particular three values, where this particular value in the middle, okay, this value in the middle, okay, is what's known as the median. This value here on the lower, for the lower box, or the lower line, vertical line, is what's known as the first quartile, and this value up here is what's known as the third quartile. Okay. So what we've done is we've created a box, okay. We have the median, the first quartile, and the third quartile. Then what we do is we demarcate what's classified, what's defined to be the lower bound outlier range, or the lower bound outlier demarcation point, okay. And typically these lower bound outliers, let me symbolize them by LBO, are any values, okay, that are 1.5 times the interquartile range. This distance here, okay, is known as the interquartile range, okay. So we can actually measure that distance because we know what this value is here and we know what this value is here. We take the first quartile away from the third quartile, so actually this value here is Q3 minus Q1 is equal to the interquartile range by definition. So the lower bound outliers are any values that are less than the first quartile and less than the first quartile by 1.5 times the interquartile range. So they're Q1, any values that are less than Q1, okay, minus 1.5 times the interquartile range, okay. Now, if you look at this particular data set here, okay, the interquartile range is this distance here. So 1.5 times that distance probably gives us a distance of about this, if that makes sense, okay, between these 2 points here. So 1.5 times it less than the first quartile would give us a value out here somewhere, okay, would give us a value out here, and 1.5 times, okay, if that makes sense. But our data set doesn't have any values that are outside that particular range. So what we do is we just put a little whisker here at the smallest value in our data set to demarcate that this is the smallest value within the data set and that there's no values less than it, okay. With respect to the upper bound outliers, well, upper bound outliers are 1.5 times the interquartile range greater than the third quartile. So it's Q3 plus 1.5 times the interquartile range. Now, with respect to this particular data set here, okay, when we look at this data set, okay, once again, the interquartile range is here. 1.5 times it would probably be about that distance here. So I need to add that onto the third quartile, and you can actually see that I'm going off the sheet here, okay. So our upper bound outlier positions, okay, we have no upper bound outliers because we've no values that are beyond that particular demarcation point. So what we do is we put a little bit of a whisker in here, okay. And hopefully what we can actually see is that this particular chart here, okay, this particular chart, okay, is what we define to be a box and whisker plot. It's a 5-point summary, includes the median, which is in the center of the box, includes the first quartile, which is the vertical bar that starts the box at one of the lower values. The third quartile is the vertical bar at the end of the box, okay, or that demarcates the closing position of the box. The lower bound outliers are any values that are less than 1.5 times the interquartile range, okay. But when there's no values less than it, we actually demarcate that particular point, okay. We demarcate that particular point at the lowest value. And similarly, in relation to upper bound outliers, there are any values that are greater than Q3, the third quartile, by 1.5 times the interquartile range. And in this particular case, we also have no values that are greater than the largest value in the data set. Okay guys, so really what I'm saying here is this is to construct a box and whiskers plot by hand, we need 5 measurements. We need the median, the first quartile, the third quartile, the position of the lower bound outliers, and the position of the upper bound outliers. Okay, that's really it. So once again, guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. The next video in this series will take a raw data set, its group frequency distribution, and will construct a box and whiskers plot. Okay? And I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you. And thank you for watching. Okay, bye bye.